In spite of the digital era, the advent of e-books, electronic media, huge amount of information stored on soft copy on internet, still the fact is that we love books. Books are very near and dear to us, and we always love to purchase books, smell the first smell and get nostalgic into books. Books are still considered to be the best friend of ours, whether it is mathematics, physics, geography, political science. We still value books and we spend a lot of time in selecting the right book. Now here is a problem that if you're not selecting the right book, then we might go into something else. We might lose the interest of the subject forever, and we might go into a wrong path, learning the wrong concepts and thereby falling into an eternal problem. Well, today's video is all about selecting the right book. What are the factors? What are the important critical factors that you should keep in mind while purchasing a science book? By science book, I mean to say it can be mathematics, physics, pure mathematics, anything related to science. So in this video, I would be talking about few important factors which you should keep in mind while you're selecting or purchasing a science book. I can guarantee you, with my experience reading so many amount of books, these are the critical factors, and if you can note them and if you can search that these factors are present in the book, I can assure you that book won't be a wrong book, but something which will help you to learn and get a complete proper understanding of that subject. My name is Shaunak and you're watching this video on my channel, and today I would be talking about the critical factors that you should keep in mind in order to select a perfect science book. Well, first, as you can see right on your screen, is that first factor is that in general what we mean by brevity is that we should it is something which is written in short, very precise, very concise, and does not carry too much of clarity. Now here you might argue with me that science and mathematics, mathematical equations, physics is all about making big things coincide and turn into small. It is writing a huge amount of literature where we can just write a square plus b square equal to some value. Yeah, you are absolutely right, but understand that when you're learning or when you're developing the concept of a subject, brevity or concise or too short writing sometimes create a problem. Let me show an example. Right on your screen, you can see that it is written that derivative in calculus means rate of change. Now, if I just say somebody who is just learning calculus, then these things might come as a problem. It might come as a confusion. Instead of that, if I write this, the derivative of a function measures how its output changes as its input changes. Doesn't it sound better? Doesn't it sound much more clear and gives you a clarity? So remember that when you're learning a subject right from the base level, for example, classical mechanics, thermodynamics, calculus, higher level like topology, differential geometry, relativity, select a book which is not always mentioning things in a precise, coincide and a short manner. And that is why I always say that a thicker or a fatter book is better than a slimmer book. You might say, oh my goodness, this is 800 pages, how I'm going to learn? It is a big book. But no, 800 pages means it can be 300 or 250 pages. But the author has taken the time, the author has taken the patience to expand a particular concept to more than 300, 400 and 500 pages. Does not always mean that it contains a lot of mathematics or it is difficult. No, it is expanded in such a manner so that the concepts become easier. Let me give you another example. So you see something that changes the motion of an object. Now, if I say something like this, what does it mean to change the motion of an object? Right on your screen, you see, does it mean to make the object move faster or slower or in a different direction? Things are not clear. So I'm just giving you examples so that you can understand how brevity or writing things in a concise manner sometimes create a problem. Let me show you another example. Right on the screen, you see the power to which a number must be raised to equal another number. Now, what is that? Actually, this definition is very brief, but it is incomplete. It does not explain what a power is or how to calculate a logarithm. So in order to take this point further, remember that when you are selecting a book, especially when you are an absolute beginner or any subject, not only basic mathematics or classical physics, it can be advanced subject only, select a book or go through the book, understand that it is not always very concise or written in a very summarized manner. If you're not aware about those concepts, it might in a proper manner. Now, once we talk of brevity, we understood that this creates a problem. But is it that brevity is the only problem? We can expand things much bigger, but is that expansion or elucidating a particular concept is all that matters? Really not. We require something else. What is that something else? Coming up in the next part of the video. Now you see, this point is very important. A book that has got holistic previews. Now let me show you on the screen what I am trying to say. Now you see on the screen I have given, this is a excerpt from a book which shows that things should be holistic. The concept that I am learning, at some point of time it should go back and give you a holistic review. For example, major components of quantum field theory, this. That means whatever the equations or mathematics that this book has been teaching us, but after some time it gives you a holistic review. That means even if I ignore mathematics, even if I ignore the complex equations at one point of time, I can just go through the normal English words and I can understand, okay, so this is another. So you see another on your screen, points to keep in mind, big picture of the goal. That means whatever the points that you have to keep it in mind, whatever the big picture it is, whatever is important that you might be not registering while you're doing this book, that should be mentioned. So when you're just perusing through the book, or when you're just flying over the pages of the book, try to get in that after a certain chapter, after certain phases of the learning of the concept, calculus, differential geometry, mathematics, whatever, does that book give you a holistic understanding? That means in plain English literature, does this book give you a basic understanding that, okay, these are the key points, this is the summary that you should keep in mind? If the book gives you that, then this is the right book, because you understand that going through the complex mathematics and equation, after a certain point of time, we feel, let us look back finally what we have understood. Now, this question that finally what we have understood, what is in there, that is basically giving you the holistic review. Now, whenever we are talking, what about if we try to give it in a kind of a picture? Won't that be much more attractive? Let us see into that. That has got schematic diagram summaries. Now, there is a old saying, I don't remember, is that a picture is worth of 100 words or something like that. That means whatever the reviews or the holistic reviews that we just talked about, if we try to put it in a photograph or an illustration or a schematic diagram, seeing that picture as a whole gives us a much more intuitive understanding, much more clearer understanding. Right on your screen, I have just given you few of the illustrations. As you can see, phase waves, etc. Then there is an electron hole and a conduction band. So there can be numerous examples given on the understanding of the schematic diagrams. Yes, schematic diagrams not only help us, but you will see that even in your childhood, on your early days, when you are going through a book, a particular picture becomes so nostalgic, something that gets in our brain so differently that whenever we are talking about that subject, we always try to remember and we try to recall that particular picture. So what does that schematic diagram actually helps us? Let us quickly look into the points on your screen. It helps to visualize complex concepts. It helps to simplify complex concept, helps to clarify complex concept, helps to reinforce learning, and used to troubleshoot problems. Absolutely, because these things are quite evident, because you can clarify, you can simplify, and once you visualize, it will help to reinforce learning, and definitely it will help you to troubleshoot any problem. Because given, say for example, how many types of classical mechanics, how many types of branches of mechanics follows, then if I, instead of writing, if I give you a kind of a illustration, then you see those this T structure and the branches and the sub branches, and immediately you can recognize. So a book that gives you a schematic diagram is definitely considered to be a positive part, and you should select a book that contains a schematic diagram. Now, when we are talking of the schematic diagrams, you understand that one particular branch goes into the second, to the third, and the fourth. Now, if we can trace it back, sometimes from the fourth we go to third and then to the second, it might sometimes require that we need to go back to our basics. We are learning calculus, but maybe we need to go back to algebra, or maybe trigonometry, or maybe mensuration. The question is that, will a book provide those things going back to the basics? Will it be considered as something as a positive trait? Reviews background materials. This is super important. This is very important. I think if you have seen my other video, that how to select a correct book in mathematics, which I have made a few weeks earlier, there also have talked on this point, but this video particularly is more about something very precise. Now, say for example, I just told you, when we are studying advanced concepts like topology, differential geometry, we might have to go back to hyperbolic geometry, elliptical geometry, a little bit of the parallel postulates. Now, again, then we have to select a book. We have to go back and find out, okay, give me the book of Euclidean geometry. No. So you should select a book that reviews background materials. That means if at some point of time you need a little bit of the background materials to be brushed up, to be again looked upon, then that book should contain. So here are some important points right on the screen. It starts with the basics, yes, because I am making now a series of videos on quantum field theory. Thanks to you that the first video went quite good. Now, when I'm constantly making what are the mathematics required quantum field theory, you see I am going back to classical mechanics, classical field theory, quantum mechanics. That is called reviewing the background, and a good book should contain reviewing of the background materials. Second is historical context. Obviously, the first video that I made, what is the best book on quantum field theory, that 1000 pages book, you see, it contains more of the historical context. It is required, because otherwise, how will you understand why QFT came? What are the limitations of quantum mechanics? How was the history of complex equations and Schrodinger's equation came into being? So yes, second point is super important, historical context. Third one is short reviews of relevant background. Not necessarily that you have to again go back to Newtonian mechanics, again go back to trigonometry, but just a short review, a kind of a quick brushing up of the skill, so that these things are better. Special boxes, you will see there are many books which gives you special boxes right at the margin or at the below. Why these special boxes are given? Because the author does not want you to get disturbed in a kind of a reading. So some boxes are given. So box number 1 gives you a kind of an idea about trigonometry. Box number 2, maybe this formula. So that is important. Cross references and online resources, very important, because nowadays when we used to read books, there were no online. We were given a kind of a CD at the back of the book. But yes, cross references, that means if you really want to check on certain concept, certain ideas which are very intense and the author wants you to go back, the author will give you either cross reference, or nowadays in the books the hyperlinks are given. Even online books, the hyperlinks are given very well. You can go there and you can check on it. So these are the important factor, that going back to the basics, there should be a proper review, proper material, small boxes, so that you can brush up the concept and you are not losing the basic concept in order to understand the advanced concept. Now the question here arises that instead of going with the basic concept, you will find some of the books specializes more on the advanced or the peripheral understanding. By the word periphery, I mean to say, for example, you are learning quantum mechanics. The book goes around quantum field theory, string theory, quantum electrodynamics. So the question is that these peripheral learnings, around the basic concept, does it really help us? Only on the basic concepts, not on the peripheries. I have seen numerous books which, instead of talking of the basic concept, diverts too much on the peripheries. I give you an example. In order to learn quantum mechanics, if I teach you more of quantum electrodynamics and quantum chromodynamics and what is a string theory and what is a gauge theory and symmetry and all those stuffs, what will happen is that when I come back to the basic concept, you are confused, you are perplexed, you are totally in a soup. In order to understand the basic concept, you are lost. And because these advanced concepts sometimes sound so romantic that you might feel, okay, let me go a little bit into quantum chromodynamics. What is the string theory about? What is those extra dimensions about? I hope I can make my point clear. So there should not be too much of peripheral or the surrounding things understanding. Rather, you should select a book that concentrates on the basic area. The next point is this one, a book that have exercise with proper return on investment. Now you see, whenever you are selecting a book, there should be a necessary ROI, or we call the return on investment. That means not only the knowledge, but you should be able to do the sums, the exercises, so that you can do well in your examination. Now when I'm talking of that, it does not mean that the mathematics or the exercises are so difficult, so immense, so complex that you take a day's time in order to solve one problem. So that should not be done. So right on your screen, you see I have given one example of special relativity. Just whatever you have learned. Then next on the screen, you can see something on Euclidean space. Just what you need to do. That means, for example, you're learning a basic concept, maybe trigonometry, linear algebra, quantum mechanics, wave mechanics, whatever. Only that portion of exercise is required, which will make you the expert of that particular concept. Now, there are books you will see where the exercises are so difficult. So I would recommend that please go for a book where the exercises are not that intense. They are proper and there is a proper return on investment. That means whatever the amount that you are spending in purchasing the book, not only the knowledge is with you, but also you can do proper exercises. The question is that when we do the exercises, how do we do that? Is it that we take the entire concept of the book total, or we divide those concepts into small block steps rather than large ones? What do I mean by that? That means when I'm going through a concept, instead of making the concept make you understand in one single attempt with lot of complex mathematics and equations, the book should be divided into simpler step ones. Right on your screen, as I have put it, putting it all together. Now, this is an excerpt from Professor Leonard Susskind's book. That means a concept has gone, whatever, quantum mechanics, classical mechanics, whatever, and then he's putting things together. What does it mean? That means the entire holistic approach of that particular lesson is now being segregated into certain blocks. It is divided into certain blocks. That is why he is saying putting it all together. That means I'm putting this part, then the second part, and the third part, and the fourth part, and so on. So instead of taking a large step where we make things very complicated, it is better that we take small steps. Why small step? Because if we are unable to understand a specific step, we can immediately go back. And that is why I told you that brush up of the basic foundation is important. We can go back, we can understand, and then we can again go forward. So dividing it into simple blocks are very, very important. Not only that, dividing it to simple blocks are important, but also another thing is important. What do I mean by that? All books uses examples. What do I mean by simple concrete examples? Now you see what happens typically is that I understand that professors or celebrated authors would say a very rigorous foundation of mathematics is required. Everything cannot be expressed in simple language. You need to learn set theory, you need to learn linear algebra, you need to learn real analysis, complex functions, etc. in order to understand this concept. But I can tell you with confidence, I've seen a lot of books right on that rack. There are so many books which I would have shown you. There are so many books which are written by celebrated authors, but they use very simple mathematical, or would say simple concept which can be related into daily use. That means it is not always that mathematics, as you understand, mathematics is a language. So when we are communicating over a language, we can communicate anything. We can use a daily usage like the trucks, the cloud, the sun, the pen, the elephant, etc. and make things communicate. So if mathematics and physics, especially mathematics, is being a language, why it is always required that we need to have a rigid, solid, strong, concrete foundation with those all symbols and then only we understand mathematics? Absolutely not. So we can use, and there should be a book which uses simple examples, although these examples sounds trivial, sounds funny, sounds foolish, but no problem on that. In order to make things understand, you have to select a book, or rather a book which should have those concepts which are very trivial, very simple, but they can be related. And only when you can relate a language to your language, only when you are able to understand whatever is being conceived over those complex equations, mathematics or physics becomes equally interesting. Now here is a problem. When I am using the word trivial, easy, that can also create a problem. Shown that what is the problem that use avoid terms such as simple, trivial and obvious. Now what do I mean by that? Now see, these terms are actually relative. What is simple to you might not be simple to me. What is difficult to me might come simple to use. So if the author assumes the word that this is very simple, this is quite obvious. When I'm telling this is quite obvious, what does it mean? That means I assume a certain level of knowledge. I assume that you know something. But as I told you, that book should start right from the beginning. So usage of trivial, simple, obvious, so easy should be avoided. And these are the points that you should keep in mind. These words can be subjective. These words can underestimate certain people. These words sometimes comes as a discouragement. And these words actually has lot of cultural and what we call educational differences. So you are telling to me this is trivial. You are telling to me this is easy. But it is not easy to me. Culturally, there might be a difference. Education wise, there might be difference. So let us avoid any book which uses the terms like clear, obvious and trivial, because these are not the way author should proceed. So select a book which will avoid those things. So that is very important. I would like to make a quick summary. Point number 1, avoid brevity or writing it in very small coincised manner. That creates a problem. A book should have an holistic approach. That means at certain point it should pause and give you a summary and a total understanding over the thing, devoid of the complex mathematical equations. There should be proper diagrams and there should be places or small boxes in the margin where you can go back and review the basic concept. The book should only and only concentrate primarily on the basic concept. Do not go around the periphery, and there should be exercises, but exercises not so difficult that you take a lot of time to do that. And there should be small steps that can be taken. There should be concrete, simple examples. All they might sound very trivial or very foolish, but that should be able, you should be able to relate that. And the book should avoid terms such as simple, trivial or obvious, because there are cultural differences and these are very subjective. I hope you liked this video. I just wanted to put these very important points. If you take these points into your mind and then select or purchase a book, I think you will make the right selection. Thank you for watching this video. If you have liked it, please put up your comment and hit on the subscribe button. And do not forget to click the bell icon so that you get all the notification from Physics for Students. Thank you very much for watching this video. Physics for Students will be soon back with many surprises. So keep watching. Thank you very much.